All right, we're moving on with our parallel circuit part of the experiment F. And for that, I'll pop over to Schoology. And we'll be looking at experiment part 2 and a little bit into analysis part 2, but that'll actually go into a different video as well. So the experiment part 2 here, it's actually really similar to what we did with our first one. So I'm actually going to use the exact same table that I've already set up for this, with the exception of I'm going to remove these measurements just because although some of them you will find are the same, some of them are different. We can use the same resistors in the different circuits. That's okay. Again, follow the rule where 2 of them may be the same, but all 3 of the rest have to be different from all the others. And then we'd have circuit 4 and circuit 5 down here. I want to make the same measurements. So when we start this off, we have a circuit with just a battery and a 10 ohm resistor. This will actually look exactly the same as how we started it last time. So I'm going to drag a battery down, going to pull in my resistor, going to bring up my wire there, and it flows. So I want to measure voltage again. Keep that, I can keep it over here, measure the voltage, and of course, this is going to be exactly the same as what we did before. So we get 9 volts there. If I measure the current coming out of the battery, it's 0.9. If I move these up to my resistor, I'm going to get 9 volts there and measure it there, 0.9. So that's actually no different than what we had before because it's the same circuit. But now it will get quite different when we start adding resistors. So now I want a 25 ohm resistor in this, but this is a parallel circuit. And so what a parallel circuit means is that the electrons will actually have a branch, 2 different branches or more to choose from. So instead of breaking this apart and then squeezing another resistor in, what I'm going to do is actually put the other resistor up here and allow these to branch. There and there. Now we can see resistors, or electrons, sorry, are flowing in different paths. They come out of the battery, they come up here. Some are going through our first resistor, some are continuing on through our second resistor. And then they come back down and recombine and go back into the battery. I do want to change, I forgot about that. Do want to change this to my 25 ohms, be careful with that. Notice how the stripes on here get different color. That's actually a code that's used in real resistors of this make, that if you know what the different colors mean, you can actually say by looking, oh, that's this many ohms in this resistor. And so it is actually following that. Now, for voltage of that, I'm going to measure the battery voltage by putting the probes down here. The battery current by putting it right after the battery in the circuit, and I'd go and I'd record those here. Oops, sorry, here and there. And then I want to make a voltage measurement for each resistor and a current measurement for each resistor. Voltage doesn't really ever change. It's always going to be about the same. So I'd put one there, just put it in the circles for that resistor. And when I'm moving on to the second resistor, into this circle, into this circle. When I'm measuring current though, I'm actually going to put it right on the resistor. And that'll tell me just the amount that's going through that resistor, not any other part of the circuit. So I've got to, I'll record it like that. And then when I'm ready for the next circuit, I'll go up and I'll put it over next resistor. I'll put it over right over that resistor and record it here. Right, so again, important to keep 25 ohms. That's with these two. 10 ohms is with the one above. When I'm going on to my next circuit, I'm going to remove my measurement tools here for the time being. I'm going to make another rung on my ladder. Notice that this is looking like a ladder as we're adding branches. So I'd bring out, this was a 10 ohm, so I don't even have to change this one. bring out the wires, connect them like this, and we have an even additional path for the electrons to go through. They can only go through one of these each. So some resistors are coming up, some are branching off here, some are going up, branching off here, and then the remainder are continuing on. Notice as you're building these, you'll be making the measurements and making some observations doing that, but also just notice the imagery that this simulation uses with the speed of the electrons, and notice where it's moving fastest and moving slowest, and that's sort of clues to what's going on in this part of it. Now on to the, I'm going to show you a little bit about the analysis, and then I'm also going to have another video showing you how to draw this kind of circuit separately. So the next part of this is analysis part 2, which looks like the previous analysis. Here is the draw 5 parallel circuits, and I'm going to break off and do that in another video. And then over here is, just like the previous analysis, calculate the total resistance of each of these parallel circuits you built. Do this using Ohm's law. Review that again if you need to. And again, we're going to use the battery voltage and the battery current measured in each of our 5 circuits. We're going to have our table with circuit 1, 2, 3, 4, 5, and then the total resistance. And again, we're going to use now the battery voltage and the battery current and make a calculation on that using Ohm's law. So make sure to review that and make sure you know how to use it. Same then when we go to circuit 2, the battery voltage that you measured there and the current coming out of the battery voltage, current coming out of the battery. Okay, that will cover it for this. Look for the circuit video right after this one.